Hello Algebra 2 students. This is the video for example 2 for section 1.2. We're going to reflect a function across axes now around the x and the y axis.
Part A. Graph f of x equals 2 times x minus 6, and the function g, a reflection of the graph of f across the x-axis. How are their equations related?
Okay, so they're going to graph, and we're going to reflect it about the x-axis and see how the equation is related. You can use a slider to reflect the graph. So here we have f of x equals 2x minus 6. To reflect it about the x-axis, which is here, this 0, negative 6 pops up to here to 0, positive 6. And the any xy, and they chose this. I mean, it looks like they're at 4, 2, but they're just using it as xy. What? Maybe I should be a little more specific. This was at 0, negative 6, and then it became 0, 6. Can you see what happens to the x and the y? The x will stay the same, and the y value gets changed. The sign gets changed. So instead of xy, it's going to be an x negative y. Then we have to come up with the, whoops, let me get to the graph. So then when I graph those 2 points, connect those 2 points, I have this equation. And if you wanted to use y equals mx plus b, you might notice that it has now a positive 6 for an intercept, and the slope is negative 2. Here it is, where the original one was a positive slope 2 and a negative 6 for an intercept. So they just changed the sign of both parts, the intercept and the slope, the sign changed. So that's why they rewrote it like this. If you ever have a reflection about the x-axis, g of x will just be the opposite of whatever f of x was. The function g of x is the opposite of the function f of x if we have a reflection about the x-axis. Now let's see what happens if we have a reflection about the y-axis.
Part B. Graph f of x equals 2 times x minus 6, and the function h, a reflection of the graph of f across the y-axis. How are their equations related?
Okay, so we'll graph the original one again. Now we're going to reflect it about the y-axis, so this gets flipped over to here. But first, where does the 0, negative 6 go? If it reflects about the y-axis, well, it's on the y-axis, so it's not going to move at all. It's still at 0, negative 6. And this point that's at xy, which is really 4, 2, reflection about the y-axis is going to bring it over here to negative 4, 2. So that means what happened? 4, 2 to negative 4, 2, the y value stayed the same, but the x values changed. The x went from x to negative x. And then when I connect those, I can write an equation. Notice the slope. The slope changed from, what was it previously? Positive 2. Now it's negative 2 for the slope. But the intercepts stayed the same. So how can we note that? Well, you can go through this. If you can look at the Envision site and go through this. I'm going to save time on the video and skip over. That it really just ends up being, we're going to negate the x. For some reason I can't highlight that. But we're negating the x in the function. So when you negate the x, you have 2 times negative x minus 6. The 2 times negative x becomes negative 2. That's how the slope changed. But this didn't change. The intercept did not change. This is key here. If we ever have reflection about the y-axis, excuse me for doing that. If we ever have reflection about the y-axis, the function h has a slope that's opposite of the slope of f of x, but it has the same y-intercept. Okay? Now we're going to apply that to 2 problems, I think. For try it, they're wondering what's the equation for the reflected graph if they reflect y equals x squared minus 2 across the x-axis, and what is it if we reflect x squared minus 2 across the y-axis. So you may want to sketch those out like I did Oh, why not? I'll show you what I did. I mean, I didn't sketch it out yet, but I'm going to use graph paper. Go ahead and click pause and come back when you're ready. I've already forgotten which was first, across the x-axis. All right. X-axis is this right here. Y equals x squared minus 2. Well, y equals x squared goes through the origin like this. So minus 2 would be dropped down 2 units. So let me do that. Down 2 units. I'm going to use, well, that's not a very good drawing there, but I'm going to say this is 2 units. So it's down to here, and it comes up there, it goes up here. Now if we reflect this about the x-axis is this one right here. This point here pops up to 2 units above. This point here, wherever it intersected, reflecting about the x-axis doesn't change it at all. Doesn't change this at all. Again, I didn't do a very good drawing of it, but so that means here's the graph of it. Now, how do we come up with the equation for that? Well, if you recall, when it's reflection about the x-axis, that was the one, and I can go back a couple screens, I think, to help refresh our memory. Reflection about the x-axis, that was this first one. That's where they just negated the whole function. So I'm going to negate the whole function. I'm going to go the opposite of x squared, and I'm going to go the opposite of negative 2. Here's my equation. Because that's when it's a reflection about the x-axis, you just negate everything in the original. Let's see what they wrote. Y equals negative x squared plus 2. Okay, now we're going to try this with the reflection about the y-axis. So if you want, I would start with another graph. Then I'm going to reflect it about the y-axis. Click pause, come back when you're ready. All right, y equals x squared minus 2. Whoops, that's not what it is. Right, it's 2 units down. 2 units down, I'll do a rough sketch. And it goes up that way, and it goes up that way. If I reflect it about the y-axis, this point here stays because it's already on the y-axis. This point that's over here flips over to this side. This point that's over here flips over to this side. It ends up being the same graph. It ends up being the same equation when you reflect it about the y-axis. But let's recall, let's pretend we didn't know that. And you don't have to graph it to come up with the equation. We could just use this rule that they gave us, and that is that we're going to negate the x in the equation. So let me negate the x. When I negate the x, instead of x squared, it's going to be negative x squared. Don't mind me, I'm going to turn off my phone. My phone's ringing. Okay, excuse me for that. When I square the negative x, I still get x squared minus 2. Okay, let's see what they wrote. They wrote that it's still y equals x squared minus 2. Yep. Okay. And that's it for this video. Let's see what the problems were. These are the potential problems you could be assigned by your teacher. 16, 22, 23, and 14. That's it for this video. Have a great day.